Welcome back to Turpentine VC, a podcast where we discuss the art and science of building successful venture firms, VC to VC. In the episode ahead, Tom Tunguz, GP of Theory Ventures, returned to the podcast to talk about the past, present, and future of data businesses, specifically through the lens of Databricks. Tom offers a bull and bear case for Databricks, an analysis of the market and main competitors, and what's next for the data landscape in the AI era. Let's dive in. Tom, welcome back to the podcast. Thanks for joining.
Oh, pleasure to be here. Thanks for having me on, Erik.
So we're going to cover Databricks today. Maybe let's start with your journey with Databricks, and when did you think, hey, this is going to be a pretty spectacular company?
I remember meeting them at the A and the B. I mean, meeting Ali, and he's a force of nature, and clearly, he was coming out of the Berkeley labs, and they were commercializing Spark. Spark was a very difficult technology to run by yourself, and Databricks was building software to manage it. Maybe it was the B and the C, not the A and the B. And many of the leading data scientists were using this technology as a way of manipulating enormous data sets to get them from whatever unstructured raw place they were into whatever place and packaged output they needed to be. And I think he's just done a phenomenal job building a really aggressive company. I think the story, one of our founders is building within the data ecosystem, and he went to an event with Ali. And I think the story really sort of encapsulates his business aggression, which in my view is an extremely good thing. He said, he got on stage talking to all these different startups, and he said, we would love to partner with you, and we will be competing with you. So if you win, great, we'll work with you. And if we win, well, we win. I don't know if it's exactly what he said, but that was his sentiment, which is, this is an open, competitive playing field. We are playing to win. Let's be aggressive.
Yeah. And talk about the company itself. What do you think was sort of the insight, or what do you think about what makes Databricks so special, or what makes it work, and situate it within the larger kind of context of the market?
Yeah, good question. Okay, so let's say you're building within the data ecosystem. Then the classic data infrastructure has been, the output has been BI, right? Business intelligence. The CEO wants a dashboard of how many widgets am I selling per region per month. And the way that that's built is there are transactional systems. So let's say you have a point of sale system that measures how many widgets you sell. That data is moved from the point of sale database, which is called the transactional database, using ETL. It's basically just extraction, transformation, and loading pipes like Fivetran, into a cloud data warehouse like a Snowflake. It's then in Snowflake, it's manipulated, reconfigured, and then goes into a dashboard. That's what we would call sort of the modern data stack. And that works really well for relatively small data volumes, and it works really well for structured data, numbers, things that you would find in an Excel spreadsheet. There's this entire other world of what's called unstructured data, which are things like raw text or video or images, and even really, really large files, where that doesn't work because it's really expensive. And because they're so large, the latency doesn't matter so much. You may not need down to the second latency. And so what you want are bigger systems that are burlier, that can handle much larger data volumes and can parallelize them and manage them over large numbers of servers. And before the world of Databricks, there was a technology that was called MapReduce that Google had built that did this, and which became commercialized in Hadoop in the form of Cloudera and Hortonworks and MapR. Those were the three companies that were sort of building this technology. And the way that it's been described to me as sort of the most tangible difference between these two technologies is Snowflake is really to deal with data frames, and then what the Hadoop vendors, those were built by people who were file systems people. In other words, how do I manage logs files or video files? And even when I was at Google, I was trying to play around with MapReduce, and I had a really hard time. It was very difficult for me to understand, how do I set up a map? And the reason it's called MapReduce is a map. This is how all these fields map together. And then here are how all the files kind of compute and go out and get you to a reduction, which is that particular nomenclature for an output. And so what Spark said is, okay, file system people built this really sophisticated thing that can manage unstructured data and process it. But a lot of data people are having a hard time. So why don't we build this really sophisticated pipelining infrastructure at scale in a way that data people can understand? And so that's a very simple sort of reductionist view of why Databricks has had so much success is because data people now can take advantage of absolutely massive computing resources to build these data pipelines. So what are some of the applications of a big unstructured data pipeline? Let's say you want to train a machine learning algorithm to identify license plates on, I don't know, at the scale of New York City Police Department. Well, you use Spark. You'll use Databricks' core open source technology, and you'll piece together a constellation of different open source projects to take those video files, put them into a folder, effectively process them with code, and then spit out an output. And a lot of the times that output is just either refined files, but now you're seeing Databricks actually starting to compete with Snowflake. You can look at the data warehousing revenue has 4x'd in the last year. It's gone from about 100 million to 400 million in a single year. And 2 years ago, we would ask enterprise buyers, are you using Databricks for BI? And the answer broadly was no. It was very difficult to find anybody. And now we're hearing about them more and more. So these two worlds of the structured data and unstructured data are starting to converge. And that's why there's increasing competition between Databricks and Snowflake.
Why didn't the solution exist before Databricks? Like what took so, was it sort of, this had to be the right time for the company, or was it just too hard to do? Or what would talk about the time, the why now?
Well, most companies were not dealing in huge volumes of data, right? Google was the first one. And, the apocryphal story is that Google, when they started, they were going to use very fancy Oracle databases, but because they were crawling the web, it was just too expensive. So they needed to build a new technology. They built MapReduce. And that's what started. But Google, there were only a handful of companies that were really operating at web scale. Yahoo also was operating at web scale. Yahoo created Hadoop. And so Hadoop and MapReduce kind of came to be. Then over time, everybody, once we saw the business model of Google, everybody in the world said, well, okay, now this is the era of data. We need a lot of data in order to compete. And so data volume started to increase, and the market size, the addressable market of people needing massive data infrastructure solutions started to grow. And as that started to grow, the way to capture the market was to improve the user experience so that the data people could actually use these technologies in a much more sophisticated way than they could with the MapReduce Hadoop world, which was targeted to basically a different user.
Did Databricks what were the major competitors along the way, or is it really just such a audacious project that they didn't have many?
It's hard to point to a competitor. It really is. I think at this point you have Snowflake's Snowpark, which Spark is Databricks' technology. Snowflake came along a little bit later and created a technology called Snowpark, very deliberately, which is Snowflake's equivalent. There's been some adoption, but it hasn't sort of derailed the locomotive that is Databricks. That's probably the most viable competitor of any sort of scale. Yeah.
And was Databricks obviously investable at what point did it become obvious that it was going to be a pretty big company?
At the beginning, I would say the venture ecosystem as a whole believed more in structured data than they believed in unstructured data. And that's because, remember, we were coming off this wave of Cloudera and Hortonworks and MapR, and there had been massive commoditization in that market. When Cloudera started, list price for a node, in other words, running Cloudera on a single server, was about $4,000. And then at the end of 5 or 6 years, it was about $1,000 a node. And there weren't that many players, but they were all trying to win relative share. And so they just kept cutting price and price and price. So there was a fair amount of skepticism, I think, in the venture community overall, that in this part of the ecosystem, somebody could charge a premium. There was also, I think, a fair amount of skepticism that was a lot of value within that unstructured data. So you think about, okay, what is unstructured data? Well, maybe it's logs, right? The value per gigabyte of a log relative to the value of a gigabyte of a point of sale system, massively different. Log's not that valuable. Very few people actually look at it. The value of one frame in a video is not that valuable. And so you have these, you're basically pressing these giant lemons, not getting any juice in unstructured data, or at least that was the perception. And whereas the converse was true within structured data. And now with this AI wave, the reality is the transformer model, well, that's totally enabled by extremely large compute and extremely large data sets. So you could argue Spark and that technology and the related technologies are basically a necessary or requisite to getting to where we have been in AI.
AI is just massive tailwinds for Databricks, basically. As the market has matured or developed, it's only just better for Databricks.
Yeah, that's right. I mean, I think the reason that there's so much interest in the company in the late stage markets And the reason why I think when they go public, you'll see a significant amount of demand is it's thought of as the AI company, the AI infrastructure company, not in the way that OpenAI is thought of as the model provider, but if this is like the data movement company. If you're moving data, if you're manipulating data, if you want to set up pipelines to train machine learning systems or modify them, you'll be using Databricks predominantly. And so that's why there's just so much demand for it.
It's interesting. So let's go to your post a bit. So you were starting to explain basically how Databricks and Snowflakes are intersecting, but let's compare and contrast the businesses a bit more.
Well, so I was at both the Databricks Summit and the Snowflake Summit, the Databricks event, which was two and 3 weeks ago, Snowflake Summit first and the Databricks Summit in San Francisco. And you can get a sense of the difference in the buyer universe. Snowflake Summit, probably director level and above. A lot of the topics covered are about transformation of a company from wherever they were to the future of data. Databricks is attended by engineers, a completely different prototype, right? Completely different phenotype of individual coming to those two events. And 5 years ago, they didn't really overlap. Why was that? Well, we talked about the modern data stack and how most of data movement, particularly for structured data, is the creation of reports. Well, it turns out that there are three categories there. There's business intelligence, Omni and Looker, and then there's data exploration where I put Hex, and then the last is machine learning systems. Historically, machine learning systems have all been post hoc, offline. In other words, CEO asks, can you cluster the customers? Who are the customers most likely to churn? What is the revenue prediction for next month? Those are not part of a product that is delivered to customers. That's something that's presented to a CEO as a report. And then when we had the launch of the Transformer, everything changed. And now everybody wants AI. And in the old world, the people building the reports for the CEO were not part of the engineering organization. You had a VP of Eng, and then you had a VP of Data. And those are two parallel structures where they might use the engineering teams were producing some of the data, and the data teams were consuming it. But that was it. That was the end of the data pipeline or the data supply chain. And now what's happening is the engineers are saying, actually, that data that we're producing around points, people buying widgets, we want you to send it to the data team. We want you to make a machine learning model out of it or an AI system. And then we want to put it into the path of production. We want to make a recommendation system or a chatbot for customer support. And so instead of the data dead ending within the data team, it's now basically a circle. The two teams are working together and the two teams are converging. And so the Snowflake people are now starting to talk to the engineers. And the engineers are saying, well, we need these production grade systems. And so these two teams are coming together. And as a result, Databricks and Snowflake users are starting to see each other more and more and more. So the big question strategically is, if you're a large company, do you standardize on one? Do you standardize on Databricks? Do you standardize on Snowflake? Do you have some teams running on Databricks, some teams running on Snowflake? And the rationalization of that infrastructure, I think, will be sort of the battle of the giants here over the next 5 years.
Hey, we'll continue our interview in a moment after a word from our sponsors. This episode is brought to you by WorkOS. If you're building a B2B SaaS app, at some point your customers will start asking for enterprise features like SAML authentication, SCIM provisioning, role-based access control, and audit trails. That's where WorkOS comes in, with easy-to-use and flexible APIs that help you ship enterprise features on day one without slowing down your core product development. Today, some of the hottest startups in the world are already powered by WorkOS, including ones you probably know, like Perplexity, Vercel, Jasper, and Webflow. WorkOS also provides a generous free tier of up to 1 million monthly active users for user management, making it the perfect authentication and authorization solution for growing companies. It comes standard with rich features like bot protection, MFA, roles and permissions, and more. If you are currently looking to build SSO for your first enterprise customer, you should consider using WorkOS. Integrate in minutes and start shipping enterprise plans today. Hey all, Erik Torenberg here. I'm hearing more and more that founders want to get profitable and do more with less, especially with engineering. Listen, I love your 30-year-old ex-FANG senior software engineer as much as the next guy, but honestly, I can't afford them anymore. Founders everywhere are trying to turn to global talent, but boy, is it a hassle to do at scale, from sourcing to interviewing to on-the-ground operations and management. That's why I teamed up with Sean Lanahan, who's been building engineering teams in Vietnam at a very high level for over 5 years to help you access global engineering without the headache. Squad, Sean's new company, takes care of sourcing, legal compliance, and local HR for global talent so you don't have to. With teams across Asia and South America, we can cover you no matter which time zone you operate in. Their engineers follow your process and use your tools. They work with React, Next.js, or your favorite front-end frameworks. And on the back end, they're experts at Node, Python, Java, and anything under the sun. Full disclosure, it's going to cost more than the random person you found on Upwork that's doing 2 hours of work per week but billing you for 40. But you'll get premium quality at a fraction of the typical cost. Our engineers are vetted top 1% talent and actually working hard for you every day. Increase your velocity without amping up burn. Head to choosesquad.com and mention Turpentine to skip the waitlist.
Present kind of the bull case and the bear case for Databricks. Like, if everything goes well, what does that look like? And if things don't go according to expectations, what does that look like?
Well, the bull case, so the company grew 50% last year, and then is on a 60% growth rate at scale. So there's a meaningful inflection in growth. Very rare to see a company actually accelerate, primarily driven by AI. The bull case is that Databricks becomes synonymous with AI infrastructure. Anybody building AI systems will be building on Databricks. Combine that with starting to win some significant share away from existing Snowflake structured data customers, and it becomes a dominant platform. I think the counterpoint to that would be Sridhar, now as the CEO of Snowflake, is able to make pretty meaningful inroads and retain and continue to grow the existing Snowflake customers by presenting an extremely compelling AI story. And you've seen that, right? At the announcement when Slootman appointed Sridhar and announced it, there's been significant recruitment of people with material AI backgrounds. You have the NVIDIA partnership. You look at what they've launched with Cortex, which is their AI product, and the announcements at the Snowflake Summit. In addition, just the cadence of PR has been completely different, much more aggressive, trying to position themselves within the world of AI, developing their own model that competes with Databricks' model and others. So I would have to say, like, the pace of innovation from Snowflake is pretty significant. The question is, will customers move? And the answer so far, at least according to our diligence, is that it's very hard for a company to move from Snowflake to a Databricks. You're talking about pretty significant change management. And so at least today, we haven't seen much of that. And then, if I could just go on for a little bit longer, one of the accelerants of that transition, and one of the justifications for the Tabular acquisition, which was Databricks buying a company that commercialized a technology called Iceberg, is the ability to move data and particularly compute. So, okay, what do I mean by that? Well, a database there's what's called a query engine. So you ask it a question, it does a bunch of math, and it comes back to you with an answer. But when it asks those questions, it reads a bunch of files. And a database is basically the combination of those two things with a bunch of other stuff, security, caching. But it's a query engine and a bunch of files. And Snowflake is a database that's optimized for a particular thing, structured data analysis. And Spark's Databricks, or Databricks' Spark, is the same thing. Well, what's happened is we're starting to see the unbundling of the database. Well, now there are many different kinds of compute engines. There's Snowflake, there's Spark, there's MotherDuck.DB, there's Presto Trino, Dremio, and graph databases. And what customers are asking for is, I want to pull my data out of the database. And why do big customers care about that? Well, it's expensive. It's expensive to store data 2 or 3 times in 2 or 3 different database vendors. It's expensive to be compliant with international law if your data is in a whole bunch of different places. And now with these AI workloads, these companies actually want all their data in a simple place, because if they decide to build some cool AI feature, it's just much easier to have it in one repo, one repository. And so Databricks bought a company called Tabular, which commercializes this data format called Iceberg, which allows you to basically move data across different workloads. So if you decide, I need a dashboard for the CEO and it has to have 60-second latency, probably going on Snowflake. But if there's something that's a little bit slower, a little bit much larger, you might move it onto Databricks Spark. And the more this trend happens where the customers are in control of their data, the more compute workloads will start to work around, the greater the competition at the query engine layer.
But you're much more bullish, right? Like of the two the cases that you outlined, you think it's much more likely the bull case, or say more about that?
Oh, I think it's, yeah, for sure. I mean, look, to see a public scale company growing accelerating their growth rate, I think they'll do just fine. We ran a linear regression based on 5 key variables, which predicts about has about prediction accuracy about 50%. That model basically predicts that Databricks would trade at about a 14x forward multiple. Snowflake's roughly around 12. But I think if it were to trade today, if it were to list, it would probably trade significantly higher than that because of the public market appetite for AI stocks, which doesn't exist. I mean, the only way you can get AI exposure today is Microsoft, which is a massive conglomerate, or NVIDIA, which is a fantastic chip company, but chip company nonetheless. And so there's a void there. And so I think when it lists, it will trade incredibly well.
Yeah, it's really interesting. If you had to put like a basket of companies that that similar to Databricks, you're making a similar kind of bet, what other companies would you put there?
Well, public is pretty hard. I mean, I think, okay, so let's say you had $1 to spend, $100,000 to buy any stock, and you wanted to have maximum exposure to AI. Databricks would be in there, Snowflake would be in there, OpenAI would be in there. Microsoft would definitely have to be in there. They have a business that went from 0 to 5 billion in run rate in about 18 months. And that's just, I think, the beginning of their ability to cross-sell. I think deeper than that, it's hard. It's hard because you have commoditization at the model layer. And we can sort of talk about that. But if you look at like the large language models, they range in sizes from about 2 billion parameters, let's say, to about 175 billion parameters. And there's a benchmark that's called the MMLU, which is high school equivalency. So how good is this particular LLM relative to a high school grad? And they're all basically converging to somewhere between 70 to 80% of the performance, even for the very, very big ones. So I think it's hard to kind of invest at the model layer, particularly in the capital intensity. So then you probably have to go application by application. Okay, let's take a look at code automation. Let's take a look at legal automation. Let's look at accounting automation. Let's look at security automation. There, the companies are much younger. So I'll probably stick with my mega cap basket for now.
That makes sense. What do you think people most misunderstand or underappreciate about the company? Or what do they not fully understand, or what do they get wrong?
I don't think the technology and what it does is broadly understood. A lot of people think about databases, and an easy mental construct for it is just a really big Excel spreadsheet. And what Databricks does is, imagine you had like 1 million Excel spreadsheets and they all had images in them. And what you wanted to do was, and all of those images had license plates on them. And let's say you wanted to count the numbers of A's and B's and C's and 1s and 2s and 3s, you would use Databricks to do that. And that's not a very sort of like grounded example, but it's just to give people a sense of scale about what the ultimate technology does. That's a really hard technical problem. And it's a hard technical problem not because the optical character recognition, or like looking at the 1s and 0s and A's and B's and C's, are hard. It's a hard technical problem because you're talking about thousands of computers all working together at the same time to achieve a single result. And so it's like I was a rower in college, and so it's like a rowing boat, but instead of 8 people in it, you have 1,000 people in it. How do you coordinate that?
Yeah, that's really interesting. What else about the company do you feel like we haven't gotten into that might be interesting for people who are either students of the company or students of business more generally?
I think a big push is the data catalog. And the data catalog was a strategic announcement for both Snowflake and Databricks at their most recent summit. Data catalog it's the address book of the data ecosystem. So let's say, Erik, you create a table about number of podcast listens by episode by date. You might own that table, right? And I would create one about venture capital investments. I would own that table, all within a company. Each of these data fields, are related in some way. They all start from the same source tables, and they all kind of evolve in a big company to the ultimate product that they'll be. And there's this strategic push to control that data catalog. Okay, that data catalog can be used for lots of different reasons. One is, I need to look up who is the subject matter expert in a 10,000 person company who owns the podcasts table. Okay, it's Erik. There's another reason to understand the data catalog, which is lineage. How do all these fields actually come together? Lineage is important for compliance. So if there's an external data set that touches social security numbers, I really need to know that to make sure it's super secure. There's data quality, which is the data that's being fed through all these pipelines actually accurate? Are the distributions remaining the same? Are the data volumes constant, so that the people who are using data can be confident in it? There's BI. Anyway, so if you can think about like the data catalog, it's basically the nexus. It's an understanding or it's a roadmap of how all the data within a company fits. And if you can control that and understand that, you can build a whole bunch of products around it. The challenge with the data catalog historically is nobody wants to update it. It's like a wiki. Somebody creates a page once and then 10 years later, somebody comes back and visits it. But it is super valuable to a company. It's like an intranet. And so now there's this strategic push to control that data catalog for both Snowflake and Databricks. There's an open versus closed source dynamic here, which also we haven't talked about, but maybe I'll just pause there on the data catalog.
Yeah. Let's talk about the open closed dynamic.
Sure. So Databricks is an open source project. I mean, Spark is an open source project, came from a lab, very difficult to implement. The commercialization motion for Databricks is the infrastructure to be able to manage tens or hundreds of thousands of machines operating this particular open source project. A little bit akin to Kubernetes, which was a technology that came out of Google. The company Databricks has done a really nice job commercializing it. When they started to move into structured data workloads, they created a technology called Delta Lake, which is effectively a cloud data warehouse. And that was closed. That was closed source, which was a bit of a departure. And I think, and I don't know this for, this is just my conjecture. I think that was basically a way of ensuring that other players within the ecosystem couldn't leverage the existing technology that Databricks might have built. And it was also a way of keeping their existing customers within a closed universe. What's interesting is Snowflake started closed source and is pushing more into open source. And so they're basically like complementing each other. One was closed source, moving into open. Snowflake. Databricks was open. It's now moving more into closed. We'll see what they do with the Iceberg acquisition. And so there's this it's like two sumo fighters trying to figure out, okay, where am I weak? How do I buttress my weakness when I'm facing my opponent? And so we'll see how this all sort of evolves. And I think one big question is Iceberg, which is a core technology of this company, Tabular, is open source today. It's an Apache license. The CEO from that company is on a steering committee for that project. And so there was a lot of questions about, does that remain open source? Is it closed source? How does this impact Databricks' strategy? My sense is they'll probably open it. I think that's sort of the illusions that they've made in the market, or they'll keep it open and open other things, but it's still completely TBD. And commercially, how will that impact the business is also unclear. Do people actually care? Does the data? But in terms of the hearts and minds of developers, open source matters a lot. And what ends up happening with lots of open source companies as they grow, as they change the licenses, as they shift to more commercialization. And it's very easy to alienate those communities. You look like HashiCorp when they changed their license from whatever open source license they had to a business source license to commercialize it more. There tends to be a lot of flack and a lot of PR management around that evolution, that whichever decision Snowflake decides to go with their open versus closed source and Databricks with their open versus closed source, whichever path they decide to go, they will definitely need to manage.
What else about the data catalog sort of, line of discussion is worth mentioning or making sure that it's being kind of fully understood here about the significance of it?
It's a strategic component to the infrastructure that historically has been very difficult to commercialize. So there are some great companies building data catalogs, but because it's not self-updating and because nobody really owns it, no one is basically promoted for managing a beautiful data catalog, it's probably a complement to one of those key products, business intelligence, compliance, data quality, security, rather than a standalone product. And so now all of a sudden, and I think we'll start to see this more, Snowflake and Databricks will start to compete or at least step on the toes of some of their key partners, particularly because they're vying for bigger and bigger markets. They want to show higher and higher growth rates. And so they'll probably start to acquire or compete as they push out. The most valuable commodity in this space is a compute workload. It's not storage, but they're related. But what Snowflake and Databricks are both competing for is the opportunity to process data. They want compute. Storage is important because if the storage is with Snowflake, then it's very easy. There's no friction associated with the compute. If it's outside of Snowflake, then you have to pay, and Amazon charges you based on ingress and egress fees moving data in and out. So there's friction there. So this is why these companies they care about the storage, but the crown jewels, the most valuable part, the filet mignon of this market is the compute. And so that's why compute heavy workloads, ETL, will be really important. materializing all these different views, like the DBTs, the five trends. I think they'll play a really key part here in the next 5 years, and it'll be interesting to see as the elephants dance, how all these businesses need to respond.
Yeah, and can you explain those businesses as well? You mentioned DBT, Fivetran. Can you give a little bit of insight into those businesses you just mentioned and how they work?
Sure. Yeah. So let's go back to the point of sale. So you and I started a business. We're selling widgets. All the data is stored within the point of sale, like a Square or whatever. And we need to move that data into Snowflake. And so we need a connector from Square into Snowflake, and then a pipeline, some computers that calculate, make sure the data is correct. If the connection drops, retry. That's Fivetran. And this is super high level. And then once it's in the database, it will be in one particular format. But let's say I need to change it in a particular format. So let's say the transactions are listed by microsecond, and I really want to see them aggregated by the month. Well, you need to transform the data. How do you do that in an intelligent way? There's a technology that's called DBT. Looker had a technology called LookML that does this too. So you can create metrics, define them once, and then reuse them in multiple places. So Fivetran are the pipes that move the data, and then DBT is, once it's gotten to its particular place, how do you reconfigure the data to be in the format that you want for the right output?
Do you have a request for startups along these lines? Like, has everything kind of been picked over, or where are
No, I think, well, a lot is changing within the sort of the modern data stack. A lot is changing when you have lots of AI-enabled BI companies that allow you to ask questions of a BI system. And I think that there's definitely a role for that. I think what will happen is you'll see a pretty significant wave of consolidation here over the next 2 years. And once the dust settles, then it will be easier to pick your spots. But right now, it's tough. And one of the reasons is the modern data stack has been very heavily financed, particularly through 21 through 23. And there has not been a lot of consolidation, aside from the very, very largest players.
That's really interesting. How much as an investor are you sort of like, hey, there's this great opportunity, like tops down versus bottoms up of like, I think this thing should exist. Let me go look at everyone who wants to do something here or is doing something here versus just kind of like responding to the like, yeah, how are you're sort of what you're looking for evolving over time?
Well, we're extremely thematic. And so we'll spend lots of time researching spaces, trying to find what's the angle, where's there a pain point, where's there a top 3 priority that's meaningfully underserved. And so we've been spending time in the modern data stack. The thing that we hear from buyers is, one, don't sell me another tool. I don't need another tool. The second is cost reduction is really important. And then the third is either my board or my CEO is really pressing me for an AI strategy. And I need an answer, but I'm afraid because I've never shipped production systems in the past. Technically, it's probably okay, but I really don't want to be fired for losing a bunch of data or exposing somebody's social security number. And so how do I make sure that those things are secure? We have looked at the large language model security space, and there are many different approaches there. So we definitely are spending time to try to understand data loss prevention and prompt injection attacks and model poisoning, data toxicity, those kinds of things. But it's also really early. I think our estimate is there's probably less than 5 million of ARR in that space today.
And when you did Looker at the A or the B?
At the A.
And when you got excited about Looker, was BI still a very nascent space, or what was kind of what did the market look like?
So in the late 1990s and early 2000s, there were four original, at least from my view, four original BI companies, just Cognos, Hyperion, Business Objects, and MicroStrategy. All those companies were worth about 2 to 3 billion, which is about 8 to 12 billion today. They were 3-layer cakes. So they had databases in them, they had caching layers, and they had visualizations on top. And they were super tightly controlled by IT. When I was working at Google, there was a MicroStrategy instance, and there was a very small team, and it took forever to get the metrics. Tableau then came out of Stanford and said, these systems are really locked down, and they're also very complicated. Let's just take the top layer of the cake, visualization, and let's have anybody be able to make a pretty chart. So that business grew to be 16 billion over the course of about 14 years, grew bottoms up $5,000 to $10,000 at a time, and spectacular outcome. And so the pendulum swung from super centralized, very structured, to very decentralized, no structure, bottoms up. That worked for a long time. Then what happened? Then the cloud data warehouses started to come around, and there was Redshift, which was the fastest growing product at AWS, and there was BigQuery, which was Google's database, and then Snowflake came around. And so the classic sort of centralized IT systems were not architected to handle that kind of a scale because the databases they had inside were for much smaller data sets. And so the idea behind Looker was try to strike a balance between centralized and decentralized control, but really build a BI system that could work natively with the cloud data warehouses. And so originally, Looker would sell and bring Snowflake in because the buyer wanted a complete package. And then the Snowflake started to grow and grow and grow. It became the other way around, where like Snowflake had actually many more AEs than we did. Not to say that Looker wasn't growing fast, but their ability to spend and their ability to raise capital was huge. And so people wanted this bundled solution. Now, the next wave of BI, we're investors in a company called Omni, which is the ex-Looker team. And they're, again, striking the balance there between centralized and decentralized IT in a really beautiful way.
Is there anything you think we didn't go into in full depth that you think we should cover more? Otherwise, happy to either on Databricks or any other company we've discussed, or happy to wrap on that.
I think one question that we are actively researching is whether these databases like Snowflake and Databricks will ultimately be part of applications, and will they serve AI models? And I think they're trying to push in that direction. They were never architected for this. But if they can push into the path of production, it opens up a new market for them. Because I think the fastest growing part of software today, in terms of venture-backed software, are inference companies. So what does that mean? Well, you have a large language model. You do two things with models. You can train them, teach them how to predict, or you can ask them to predict. And so the first one is training. The second one is called inference. For a long time, training was by far the largest part of the market. 80 to 90% plus. All the GPUs were there just to train and train and train. Like Facebook's buying 20 billion of GPUs this year. Well, just to kind of give you a sense. And then Google and Microsoft and Amazon spending 12 to 15 billion a quarter. Half of that is on GPUs just to build out data centers. And now what we're starting to see is inference. So it's actual usage. When a user asks a question, well, you have to ask for a prediction from a large language model. Where NVIDIA is trying to push into the inference market. And I can imagine Snowflake and Databricks also starting to push meaningfully into this market, because the growth rates on these companies are just enormous. Like, 1 to 20, 1 to 30, 1 to 40, 50 to 150 in a year. And that's just because the demand is there. It's a commodity, or relatively commodity market. But the total top line growth is staggering. So I could imagine acquisitions there for both of those businesses, or meaningful product pushes, and then tying the training systems ultimately to the inference is a way of keeping all the data within an ecosystem and capturing more and more customer spend, particularly for the very largest businesses.
Yeah, that's a good note. I have one more question, which is, when you talk to your peers, the people whose opinion you really respect and who know the most about some of the topics that we've talked today, and you have disagreements with them about where something is or where something is going or the state of something, what is an example, or what are some of those disagreements?
Value of NVIDIA in 3 years. I think that's a really interesting, if you were hosting a dinner, 2-3 years ago, the question was, what is the price of Bitcoin in 18 months, right? That was sort of the catalyst for a great debate. I think there's an equivalent question here, which is, what is the total market cap of NVIDIA in 3 years? And there are bulls who believe that the demand for GPUs is basically unquenchable here for the next 5 years as a result of small fabrication capacity, effectively very little in the US. Tesla is buying 15 billion of GPUs. Facebook's buying 20 billion of GPUs, and this kind of goes to the moon. And you believe that larger and larger models become more and more important, and they go from 150K a run to 10 million to train to a billion to train, which is what Amazon has had recently. And so you just have scale. Scale dominates, GPUs rip, and NVIDIA continues to go to the moon. It's already the most valuable company in the world. And then there's another view, which is Amazon and Google have their own GPUs. AMD released a chip set that's about 30% more powerful than the current generation of A100s. And this market ultimately reaches commoditization. You look at NVIDIA's revenue's grown 5x in the last 4 years. Profitability has gone from 4 billion in profits to about 46 billion in 4 years. We really have this beautiful engine of a business. And so how sustainable is that? How does that grow? As more GPUs enter the market, what does the dynamics look like?
And what do you think is the steel man of the other side, or like the best argument or something that could almost convince you, but not quite?
Of what? That NVIDIA will be worth less?
Yeah.
I think the biggest argument is small language models start to really dominate. So you look at Llama's 8 billion parameter model that was overtrained on data. It's really good. And it compares favorably to 70 billion parameter models and even some 140 billion parameter models. And then a large number of the enterprise use cases don't need parameters in the billions. They need much, much, much smaller models that can be deployed on a computer or a mobile phone for privacy reasons or latency reasons. And so these big fancy GPUs become less important. I think another dynamic there is just the competition from like Google and Amazon on the Google's TPUs and Amazon's inference chips, where the bottom falls out of the market because there's this awesome paper we studied in business school called the bullwhip effect. The bullwhip is this, you crack a whip and you can see a wave going through it. Whole idea. So in business school, we had this Belgian professor and he made us play this beer game, sort of illustrate this. And there were 4 students. One was a beer maker. Another one was a wholesaler. Another one was a distributor, the first distributor, then a wholesaler, then a retailer. And the professor would modify the demand just a little bit at the retail level, just like 1 or 2 units a week. Then it would go back up to the producer, and the producer would see these massive swings in demand. And there's this great paper from the Sloan School if you want to read it. And then that massive swings in demand would go all the way down. And by the end of like 4 or 5 cycles, maybe 10 cycles, everybody in the supply chain is bankrupt. And the producers turning to the retailer and saying, what is going on? I mean, it seems like all of a sudden all these people want this beer. And then the next week, nobody wants any beer. And you can look at NVIDIA's any one of the multiples, like EV to EBITDA or PE multiple. And over the last 15 years, you see this huge spike when gaming became really big and the next generation MMOs and the first person shooters really needed beefy GPUs. And then it surged and then fell. And then there was the next generation, which was the GPUs used for crypto mining. And so the PE multiple went from about like 15, 16, all the way to 50 or 60, and then back down to around 25. And so you have this, like, particularly at the chip layer, you have this incredible amount of volatility that exists because it's not a recurring business. It's not a subscription business. And at some point, people will have enough GPUs. And this is a big reason, and I completely agree with the strategic direction, that NVIDIA is pushing more and more into software. Again, like, I would not be surprised if they start getting in the business of inference, but they've started to push into like weather prediction and lots of different other applications as a way of diversifying their revenue and stabilizing the value of the business.
I think it's a good explanation of both sides. And how confident are you in your position?
I don't know how to answer that. I mean, I think it depends over what time frame. I was looking at leaps, which are long dated options for NVIDIA. So I think this is the question of the day, which is how long does this GPU demand last? And I don't know if I could answer that for you. So 50-50, coin flip.
Yeah. Makes sense. So let's wrap on that. For people who want to go deeper on your work, if they enjoyed the conversation here, I want to point them to your blog, to your Twitter, any other plugs that people should know about listening?
No, those are there's 3 places. There's tomtunguz.com, there's Twitter @ttunguz, and then there's the LinkedIn. So you can find the content there as well. Cool.
Awesome. Well, Tom, thanks so much for coming on the podcast, and until next time.
Thanks for having me, Erik. Such a pleasure. Talk to you soon.
Turpentine VC is a podcast from Turpentine, the network behind Moment of Zen and Econ 102. If you liked the episode, please leave a review in the Apple Store or rate us on Spotify. Hey everyone, Erik here. At Turpentine, we're building the first media outlet for tech people by tech people. We're the network behind the show you're listening to right now. We have a slate of hit shows across a range of topics and industries, from our AI and investing cluster of podcasts to shows that drive the conversation in tech with the most interesting thinkers, founders, investors, and influencers, like Econ 102 with Noah Smith. We're launching new shows every week, and we're looking for industry-leading sponsors. If you think that might be you and your company, email me at erikaturpentine.co. That's ERIK @turpentine.co, and let's partner together.